Hello and welcome again. This is Drew Rawlings and this is my presentation for my embedded systems final project. Right here I have the VS1053b and it's the master device, and it communicates via SPI to the VS1053b MIDI audio codec chip. Here I have this one right here, and the project started off with receiving this chip with no board. And so what I had to do, I had to get online and find the datasheet and find the suggested schematic for this chip. And so using Eagle, I designed a breakout board for this. And this took a lot more time than I planned on, for I found some mistakes in this schematic. And I had to research online to figure out how to fix them, to make sure when I plug this chip in that nothing's going to smoke or it's going to work correctly. So once I got the board routed, then I spent another decent time soldering on all the components. I wanted to make sure there was no shorts and just reduce the risk of error for when plugging in that there would be smoke, and then that would be the end of my project. So what I have set up now is a demonstration of how I communicate with this device. So using the oscilloscope over here. Now this device has two SPI connections. Essentially, they share the same clock signal and data lines, the MOSI and MISO, but there are two slave selects. There's a serial control interface and a serial data interface. This is going to be a demonstration for the SCI. So right here I have this is the MISO, the information that the VS1053b sends back to the VS1053b. Here is the slave select for the SCI line. Here's the MOSI, and here's the clock. So what I'm doing here for this part of the code is actually it takes 32 bits to do an SCI command, essentially. So these first 8 bits, I send it a 2 to let it know that I want to write to the device. And then here I send it the register or address that I'm interested in, and in this case I'm setting the volume. And since there is a stereo output, these next 16 bits depict the left volume and the right volume, and I just have them set for the same for right now. And now if I scroll over, this chip has the functions of bass and treble control, and also to set my high frequency limit and low frequency limit. So this is what I'm just doing, another example of writing to the chip where 2, so I'm writing, and 2 is the register that has these bass controls. And then these are split up into 4 separate bits to where I am setting the controls as mentioned. So I'm sending in AA22. And now to show that the device actually received this, I will read from the device. So reading from the device, instead of sending a 2, I send it a 3, and now it knows that I want to read. And now I tell it what register that I'm interested in reading, and that is the bass control register. So the AA22 I just sent doesn't have it decoded here, for it's decoding these, which or don't cares now. But as you can see here is a AA and 22. So this concludes this section of my demo.